Hello guys, so today I'm going to show you the reduction formula for integral of sine x dx. So what we're going to do first is to let ln be equal to integral of sine to the power n of x dx, and then after we do that, we're going to take our function and then we're going to split it into two parts. So the way we split it into two parts is that we want one part to have a power that's going to be reducing. So for example, if it started with to the power n, then it has to say to the power n minus 1 and so on. That's the point of the reduction formula. So how we are going to split it is that we're going to say sine to the power n of x is going to split into sine to the power n minus 1 of x multiplying sine to the power x, and then we're going to take the first part of the function and then we let it equal to du. We let it equal to u, and then we find the derivative of that, which is du, and then we're going to get that. Then we take the second part, which is sine x dx. We let that equal to dv, and then we integrate that to get v. So we know that if we integrate sine x, we're going to get minus cos x. So v will be equal to minus cos x. So now we have these four equations. So what we are going to do is we're going to apply the integration by parts formula, and it is like that. So I hope you're familiar with it. So what we're going to do, we're going to take u multiply by v, and then subtracting integral of v multiplying du, and then we get something like this. And then we kind of rearrange stuff and organize stuff a little bit on the right side, so we're going to get something like that. And then so we can see that now we have cos squared x inside our integral on the right side of the equation, so we need to replace that. So if we note, we know that there's this identity which says cos squared x plus sin squared x is 1. So we can use this identity to replace cos squared x. So we can rewrite this identity and say cos squared x is 1 minus sin squared x, and then now we replace cos squared x with 1 minus sin squared x, as you can see in blue right there. So, and then from this stage, what we're going to do is inside our integral, we're going to distribute that product. So we're going to say sine to the power n minus 2x, and then we distribute it inside the bracket, so we end up with something like this. And now from this stage, what we are going to do is inside our integral, we know now we have two terms which are subtracting each other. So we know that the integral of two terms subtracting each other can be replaced by the difference of the integrals. So we're going to replace that with the difference of the integrals of those two functions. So we are going to end up with the orange integral and the green integral. Then we take it on a blank page. So now what we're going to do is we have to deal with that orange integral and the green integral. So we'll start with the green integral first. So if you take a look at it, the green integral is exactly what we started with, which is exactly ln. So what we're going to do, we're going to replace the green integral with ln, and then we do the similar thing to the orange integral, but we're going to say ln minus 2, because that will be its equivalence in terms of ln. And then so we'll get something like this. And then from there, what we can see is that on the left hand side we have ln, and on the far right hand side of the equation, we also have ln. So we're going to collect like terms. So we're going to put the one on the right to the left, and then we end up with something like that. And then we do a little bit of algebra on the left hand side. We factor out ln, we're going to get something like that, and then simplify that. We get on the left hand side, we get n multiplying ln, and then so to isolate ln, we just divide both sides by n. So we end up with ln is equal to that term over n plus n minus 1 over n multiplying n minus 2, and that's our reduction formula. So thanks for watching. If you like the video, just subscribe. If you like the video, you know the YouTube stuff. So thanks for watching.